Let's look at final exam question number 51, found on page 672 of Teach Yourself Electricity and Electronics 5th edition. The question asks us which one of several methods we can use in an attempt to increase the deviation of a frequency modulated, that's FM, or phase modulated signal. Now remember, in the case of phase modulation, a change in phase is always attended by a change in frequency, and a change in frequency is always attended by a change in phase. The two are not exactly identical technologies, but they produce very similar results. The deviation is the extent to which the signal goes above and below the center or unmodulated carrier frequency, which is the timeline in this graph. This is a graph of frequency versus time for an FM or PM signal. Now, if we want to increase the deviation, we can multiply the frequency of the entire signal, because suppose that we start out with a frequency of 100 megahertz. Just for reference purposes, suppose that the signal increases and decreases by 5 kilohertz, plus or minus 5 kilohertz above and below the carrier frequency. So this thing will have a maximum frequency of 100.005 megahertz and a minimum frequency, a minimum instantaneous frequency of 99.995 megahertz. That is 5 kilohertz above 100 megahertz, 5 kilohertz below. Now suppose that we double the frequency, so that instead of a 100 megahertz signal, we now have a 200 megahertz signal. Change colors here. 200 megahertz. And we leave the modulation exactly the same. Well, we're going to double everything. We're going to double each and every instantaneous point of frequency. So instead of 100.005, we're going to get 100.005 times 2 for the top frequency, or 200.010. That's going to cause a 10 kilohertz increase in the frequency. Contrary-wise, going down, instead of 99.995 megahertz, we're going to double those points, and we're going to get 199.990 megahertz. So we're going to end up with twice the frequency of the signal itself, and also twice the deviation. So if we were to look at that on an analyzer, and they actually make analyzer scopes that you can look at these frequency modulated signals and phase modulated signals on to check the modulation waveforms, you would get a wave that would go up twice as far and down twice as far, up twice as far, down twice as far, and so on, like that. That would be an absolute graph. So the correct answer at the end of all of this discussion is C, as in Charlie. C as in Charlie. We can use a frequency multiplier to increase the deviation of these types of signals.